Right, so I want to do just one example of sketching a polar curve where uh, we can't easily convert the polar equation into a Cartesian equation. Right, so this is quite a difficult thing. Right? It's quite challenging, and one should really focus more on the case where we can convert the polar equation into a Cartesian equation, as we did in the previous video. Right. So we're asked to sketch r is equal to cos squared of 2 theta, theta between 0 and 2 pi. Right. So what we're going to do is, because we can't easily convert this into an equation in Cartesian form, right, so we're going to see, well, how does r behave relative to theta? In other words, we're going to sketch this equation on the r theta plane. Right. So doing that, let's put theta over there and r over there. Right, so theta is between 0 and 2 pi. Right. And this function is going to be periodic, and its period is going to be pi. Right. So let's see. Just marking off the right places. So there's say pi, pi over 2, 3 pi over 2, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Right. And these are the points I pick because those will be the points where this r equals cos theta attains a maximum 1 and a minimum 0. Right, so there's r equals 1. Right. So at 0, the r is going to be 1. Right, then we're going to go down to pi over 4. Up to pi over 2, down to 3 pi over 4, back up again like that, back down, back up, down, and up. Right, so it's not a very good sketch because my scale isn't always 100%, but it gives us an idea of what's going on. Right. So now how do we sketch the curve on the xy plane using what I've drawn there, right, the curve on the r theta plane? Well, remember, on the xy plane, r equals 1 is a circle, right? So let's draw that. Right. And on this side, right, so here we have the equation for the curve r is equal to 1. Right. So let's now draw the curve theta equals 0, pi over 4, pi over 2, and so forth. Right, so theta equals 0, it's there. There's theta equals pi over 4, y-axis there, theta equals pi over 2, here we have theta equals 3 pi over 4, theta equals pi, right, theta equals 5 pi over 4, theta equals 3 pi over 2, and let's do that a little later. Theta equals 7 pi over 4. Right. So now let's see what happens. Right. We start when theta is equal to 0, r is equal to 1. Right. So theta equals 0, r is equal 1. We start there. Right. And then what happens is we increase theta as we move counterclockwise. Right. R decreases to 0. We get to 0 when theta is pi over 4. So we start here, right, and we move counterclockwise, right, And remember, r gives you the distance from the origin. So if r decreases, it means we have to move closer to the origin. So we're going to start here. And we're going to move closer and closer to the origin until we get to the origin when theta is pi over 4. Right, so here we are now at theta equals pi over 4. And now what happens at theta equals pi over 4? Well, r starts increasing again until it hits r equals 1 at pi over 2. Right, so r increases means we're moving away from the origin. Right, so we're going to be here, and we now move away from the origin until we get to this point. Right, theta equals pi over 2, r equals 1. Right, and now we decrease again, right, to theta equals pi over 3. Right, we go from theta equals pi over 2 to theta equals pi over 3 pi over 4. Right, r decreases again. Right, so we do that. Right, now we're at theta equals pi over 3 pi over 4, r equals 0. Right, and now what happens to the graph? Well, r starts increasing again until it hits r equals 1 at pi. Right, so r increases until we get there. Right. So you're at pi, and now r decreases again, back to 0 at 5 pi over 4. And so moving from theta equals pi to theta equals 5 pi over 4, r decreases back to 0. Let's just get that. Right, so now we're at theta equals 5 pi over 4, r equals 0. Right, we're over there. And now theta increases to 3 pi over 2, r increases back to 1. There we go. So we sit over there. Right. And now theta increases to 7 pi over 4, r decreases back to 0. Right, so we're going like that, back to the origin. Right, and then we're over there, and now theta increases from 7 pi over 4 to 2 pi, r increases from 0 to 1. So we start at theta equals 7 pi over 4, r is equal to 0, and we increase, go back to theta equals 2 pi, r equals 1. Right. So this curve is a 4-leaf clover. Right, it's lucky, isn't it? So I reiterate, this is a difficult curve to sketch. Right? If we do ask you something like this in the exam, it will be a very challenging question. Right? And you should focus on the case when you can write down a Cartesian equation for the curve, as in the previous video. Right, once you've done with those, you can try a couple of these types.